Hello, ToobTimers. Today we're going to take a look at the Nobsound or Duke Audio 6P1 amplifier circuit. Somebody had very nicely traced it all through in their on their unit and published the schematic. And I was able to find this schematic because somebody had commented on one of my earlier posts that this amplifier was the Nobsound 6P1 amplifier. So let's start with the power supply. If you notice, they have 120 volts AC listed as the input, but however on the unit it says 110, which means you're going to be a little bit over the voltage at 120 than you would like to see it at 110 volts. That's not much of a problem. That can be solved with a little filament transformer that is wound or connected in a bucking configuration, which would take the 120 volts AC minus 12 volts AC, and it will get it down below 110, which is probably a good place to be. I will have I'll have a program that describes how to configure the bucking transformer for 110 volts. By the way, I used this bucking transformer on my Dyna kit because they're rated at 115 volts, and I bucked 6 volts to take it down closer to 115 volts. Anyways, let's start taking a look through this circuit. Now, they show the Vive Z4, which is substantially equivalent to the Soviet 5U4C tube. I would recommend using the 5U4C because it has just a little bit better characteristics than the 5Z4. So as we move through, we see we are rectifying our high voltage, and the very first thing we run into on this circuit is a 150 volt capacitor. Now, or 150 microfarad, 400 volt capacitor. Now, I have never seen a value of capacitance connected to the cathode of the tube that high ever. So that immediately set my spidey senses tingling that something's not quite right here. Sure enough, there was a skunky article that showed, hey, let's change this to a lower value. Now, where's the data that says do this? Well, it's right over here on this data sheet. This is the rectifier tube. It is in Russian. I don't speak Russian, so that's always a bit of a hassle. Thank goodness for Google. And I found right here on this line, it says the maximum capacitance that you should have off this tube is 4 microfarads. Well, you can see that's significantly less than the 150 microfarad. Why? Well, initial inrushes are very long, and they will stress the current rating of the tube. And then after that, when you're in operation, this large capacitance will be continuously having to be charged up by this rectifier. Eventually, that will wear out the tube. If you take a look at one of my earlier posts, you can see what happens when there is a tube has too much capacitance tied on the end. My Dyna kit, my ST70, says the reason why pardon me, I've had a terrible cold. My voice is a little hoarse, and my mind's a little bit flaky. But the tube that I showed actually came out of my Dyna kit ST70 because they had like 10,000 microfarads off the tube, which is bizarre. Nevertheless, this needs to be replaced to a maximum of probably 4.7 microfarads would be sufficient. Now, what that's going to do is change this output voltage a little bit, and you might get a little more ripple on there, which would show up as hum. I'll look at that a little bit later, and we'll look at it together a little bit later. Okay, so for this amplifier, I would strongly suggest that you find a bucking transformer. Probably get it on eBay, actually, right off the bat if you don't want to wire it up. So you need the bucking transformer, and you need to change this capacitor to probably 4.7 microfarads. That'd be good enough. Okay, let's start taking a look at our audio circuit. Our audio circuit begins here at the input, and it is directly connected to the grid, more or less, through this 100K potentiometer. I'm always a little bit leery of a direct connection to the grid, because if you have a DC offset from your input, from your preamp or whatever, it might, depending on your volume setting, upset the bias of the tube. Even if it doesn't upset the bias of the tube, every time you change the volume, you will change the bias on this tube if there is a DC voltage present in your input. That's probably not a terribly important thing to change at this time, something to keep in mind. The next thing, we go up to this is, by the way, what they call a cascode configuration, where you have the plate of one tube driving the cathode of the next. And there's a couple of things here that also got my spidey senses tingling. 168 volts is on this cathode. Normally, this wouldn't be quite elevated that high. There is a rating on this tube that sets the maximum cathode to filament voltage. And I have suspicion 168 volts is way above that limit. So what I'll do next is take a look at this. The 6HC is the same as, or they say, is the 6SN7, except if you take a look on this rating right here, UKH, which is the maximum voltage between heater and cathode, you have 100 volts. That's a problem, because you have 168 volts there, plus or minus the 6.3 voltage of the filament. That will harm your tube over a long period of time. Now, they like to say that this particular tube is equivalent to the 6SN7, and you can plug them and change them without thinking. There's plug and play changes. But take a look at the peak heater cathode voltage on the 6SN7. It is 200 volts. Definitely, this tube should be replaced with a 6SN7 so you don't eventually short out the cathode to the heater of this tube. I think that's a very important change to make. So at this point, we have a capacitor change and a tube change that is mandatory, as well as the bucking voltage to the input. Now, there's another thing going on here. If you notice, the grid bias is set by this 1 megohm resistor connected to the cathode. That's not a good thing to do, because as the cathode, as the amplifier changes voltage, the heater, this bias will change as well. This should be set through a voltage divider circuit where you take this off of here, ground it, and you connect this to your B+, your 300 volts, and you try to set that around 30 volts or so. So in a little later, in the next presentation, I will go over that as well. So is it a problem? No. However, you'll get more of a hi-fi sounding amplifier if you take that grid and fix its bias. The way this is done now is generally used in guitar amplifiers, and that can be looked at through the valvewizard.uk page. This is an excellent page to take a look at various amplifier designs, and there they will show you how this should be modified. Next, so we go. So the signal has come in the input through the first triode of the cascode amplifier into the second triode of the cascode amplifier and over through this 22 microfarad capacitor and into the grid of the tube, the 6P1 tube. These tubes are in parallel, which means the load resistance of these tubes should be 1/2 the recommended load or the maximum load resistance for the 6P1. Now, this comes into importance when you're dealing with this transformer. I don't know what the impedance of this transformer is. Now, what happens here is the optimum load resistance of this 6P1 should be equal to the input impedance of your output transformer. If you don't do that, you will find that it's either dissipating too much or too less energy in the tube, and you won't get your output, your maximum wattage output of this thing. So I'm going to bring up the status sheet on the 6P1, and you will see the optimum anode load resistance is 3,500 ohms. Now, because we have two in parallel, that would take us to about 1,800 ohms for the optimum load resistance of this transformer. And that I'm going to have to investigate to see if we're even close. Let's see, what else do I want to talk about here? Okay, I think that's pretty much good for today. The absolute changes to this circuit must be taking this voltage down to 110 volts. You can also do that with a variac, by the way. If you set it, take the knob off so no one changes it. So you can use the APC LE600 model voltage regulator, a variac that you set to that level, or you can use a bucking transformer. I will go over all this in a forthcoming presentation. The next must change is this 150 microfarad to a 4.7 microfarad capacitor. And the third must-do change is remove the 6HC tubes for a 6SN7 tube so that you do not exceed the heater to cathode voltages. Those three changes will give you a nice sounding amplifier as it is now. I mean, it's a very nice sounding amplifier. I like it. I read someone's article that they heard notes in this amplifier that they hadn't heard before. I agree with that. I've heard the same thing. And after that, those are the must-do changes. In a subsequent article or presentation, I will discuss the nice-to-have changes in more detail. That's all for now, Tube Timers, and thank you for taking a watch.